In section 3.3, we're going to pick up how we deal with finding minimum and maximums on an open interval, similar to what we did with the closed interval in section 1, but a different approach. And then we're also going to pick up some definitions along the way. So in the first part, let's start talking about increasing and decreasing functions. And it's where x1 and x2 are in the given interval. Where's a function increasing? This will be where x1 is less than x2. And then if it's increasing, that means f of x1 is going to be less than f of x2. Basically, as you are moving left to right on your x-axis, your y values are getting larger. And so this would be an example of that on a graph. And I don't doubt the increasing and decreasing in terms of our graphs, but I want to clearly define it so that we can see it in some examples we're going to look at. Now remember with this is a positive slope, no big deal, that's from algebra, but calculus, remember this is where you have a positive derivative. That's what I want to emphasize to you. Where is a function decreasing? That would be when x1 is less than x2. So as you're moving left to right, reading a graph left to right, that your f of x1 is greater than your f of x2. And so here would be x1, here would be x2. And that means that what are our y values doing? They are getting smaller as they move from left to right. And again, algebra, we know this to mean negative slope just reading the graph, but calculus-wise, this means that your derivative is negative. What about a constant slope or a constant function? This would mean f of x1, x1 is less than x2. And that means that our f of x1 is equal to f of x2. So as we move from left to right on a graph, we are just maintaining our values. We are not going up or going down. Now this is when algebraically your slope is 0, where calculus-wise your derivative is 0. And we've done that many times within this course. And so this first example says, find the intervals on which f is increasing and decreasing. And so I don't want to be looking at a graph and have to zoom in and go, okay, where did it start that? Where did it end it? I want very defined points and I want to find out what's going on. And so what we're going to do is we're going to take the calculus approach and we are going to look at derivatives of them as we go. So I'm going to look at the function. I'm going to say, okay, let's take the derivative of this function. So f prime of x would be equal to 3x squared minus, bring that down, that would give me a 3x. So step 1, we are going to take the derivative. After we take and find the derivative, step 2, we are going to find the critical numbers. If you need review of critical numbers, you can go back in previous lectures and we talked about that skill individually. So to find those critical numbers, just reviewing, that would be where f prime of x is equal to 0 or does not exist. And so I'm going to take 3x squared minus 3x. I'm going to say it equal to 0. There is no areas where it does not exist, so I'm just going to look at this one. Factor a 3x out, that gives me, x minus 1 equal to 0, and then I could solve. So 3x equal to 0, x minus 1 equal to 0. So I get x to be 0, and I get x to be 1. So those are my critical numbers. Once I find my critical numbers, because my whole goal is to find where it's increasing and decreasing, step 3, we are going to test the intervals around the critical numbers. Test the intervals around the critical numbers. And just remember with this, we are going to be plugging into f prime of x. Because we are trying to find where it is increasing or decreasing, and that is referring to slope, we're going to be plugging into our derivative. Whereas in earlier sections, we were plugging into our f of x function in order to find the position. This one we're going to be plugging into the derivative in order to figure out where it's increasing or decreasing. So what I like to do is to draw a number line with 0 and 1 or all my critical numbers. Now we know its derivative at this point is 0, and that's why we picked them and solved for it. So I'm going to pick numbers to the left and right of that interval. And let me just kind of move down here so we have some more room as we go. And so say I want to pick a number to the left of 0. I'm going to pick a really nice number. I'm going to pick x to be -1. You could pick anything you would like. I'm going to plug that into my derivative, f prime of -1. When I plug it in, that gives me 3 times -1 squared minus 3 times -1. So a value of 6. Now I am not concerned with it being 6. I'm more concerned that this was a positive number. And so that means I'm going to have positive slopes to the left of 0. Now I'm going to pick a value between 0 and 1, and I'm going to pick, again, a nice number for me to plug in, just a 1/2. And I'm plugging back into, I cannot stress enough, the derivative. So plugging that back into the derivative, I get the value of -3/4. And again, I'm not as concerned that it's a 3/4. I'm more concerned about the sign of it, and it's negative. So that means between 0 and 1, I'm having negative derivatives or negative slope. Then I'm going to pick a value over here to the right, a positive one. I'm just going to pick x to be 2. You could pick any number to the right of 1, 10, 20, 1.7, doesn't matter. But just make sure you're plugging it into your derivative. Plugging that into my derivative, going to my calculator, we have lots of evaluation on this exam in this chapter. Plugging it back in, this gives me a value of 6, and again, it was a positive 6. And so I'm more concerned with, look, I got a positive number, positive derivative, therefore a slope that's positive. So my main goal is to figure out where this function was increasing or decreasing. Notice if it's increasing, that is where you can see, look, we went positive, so we're going up, positive, we're going up. So where is this function increasing? Because remember, everything we're plugging in is into f prime of x. And so where is this function increasing? -infinity to 0, union with 1 to positive infinity. Now, where is this function decreasing? We're going to look here. It would be going down in this region where that has negatives. And so that would be on the interval from 0 to 1. And notice these are parentheses. These are not brackets. And that is because at 0 and 1, we actually have a derivative of 0. And so it's not increasing or decreasing. So the way that you're going to find your increasing or decreasing is find your critical numbers. Draw a number line, check values to the left and right of the number line. Make sure you're plugging into, again, stressing as much as I can, the derivative. Therefore, you can see what those slopes are looking like, and then you can make a statement about your increasing and decreasing. Now, what we can do is, now that we know that things are increasing or decreasing, we can take it a step further, and we pick up this idea of the first derivative test. And this makes it easy to locate our extrema. It says if f prime of x changes from positive to negative at c, then f is a local maximum. And let's think about why that is true. If my derivative is positive, that means it's going up. If it's negative, that means it's going down. And notice going up and then coming down creates a maximum. And so we know that a maximum would be here because it's going up and then going down. If f prime of x changes from negative to positive at c, then f has a local minimum. We'll think about your minimum. It would be going down and then going up, so this value here would be your minimum. If f prime of x does not change sign, then there is no maximum or minimum. And then they take this further and say, okay, that would be the case of strictly monotonic, and that is if it is increasing or decreasing the entire interval. Situations such as that would be something like this. You can see it's increasing and then increasing, it just changes its speed of it. Or a function like this, it's decreasing and decreasing, it just changed in speed in the middle there. And so this first derivative test we are going to become super familiar with and use quite a bit. And so let's just kind of work through those examples here. Applying the first derivative test. Find the relative extrema of the function. Now for this one, it is similar to what we saw in previous sections with our sine function. It is on the interval from 0 to 2 pi, but we are not checking, positionally, let's look at the values. We're applying, reading our instructions, applying that first derivative test. So in order to apply the first derivative test, we need to check a couple things out. Is it continuous? And yes, this is a continuous function. And is it differentiable? Yes, this is also differentiable. Next thing we need to do is we need to find the critical numbers. In order to find the critical numbers, we're going to have to take the derivative and set it equal to 0. So the derivative of 1/2 x would be 1/2 minus the derivative of sine x would be cosine x. We're going to take that function, say it equal to 0, and solve. So I'm going to add this cosine x over. So this gives me 1/2 equal to cosine x. And then you're back to your trig circle again. Where's cosine x equal to 1/2? And that is at pi over 3 and 5 pi over 3. After you find your critical numbers, you're going to be testing points in your derivative using your number line. So I always like to kind of draw my number line, put all my critical values. Now in this case, because we know that sine and cosine, some of those trig functions are cyclic, they are restricting us between 0 and 2 pi. So I want to make sure I don't pick values that are less than 0 or more than 2 pi because I'm just going to stay within this range. We already know that our derivative is equal to 0 at these 2 points, so make sure you're not plugging those back in. And then just a reminder, you're plugging into your derivative. So I'm going to pick a value between 0 and pi over 3. Let's pick, say, x equal to pi over 4. Plug pi over 4, again, plug it into your derivative. So I'm going to say 1/2 minus cosine of pi over 4. And that's going to be equal to 1/2 minus the square root of 2 over 2, which gives me approximately negative 0.207. And again, I'm more concerned that it was a negative number. So that means I'm negative between 0 and pi over 3. And then I'm going to pick x to be a value between pi over 3 and 5 pi over 3. I'm going to pick pi. I just try to pick easy numbers for me to plug in. So it would be 1/2 minus cosine pi. So that would give me 1/2 minus negative 1, which is 3/2, just using my trig circle. But again, I'm more concerned that I got a positive 3/2 in there. And then for my last test interval between 5 pi over 3 and 2 pi, I'm going to pick 7 pi over 4. And so I'm going to say f prime of 7 pi over 4. That gives me 1/2 minus cosine of 7 pi over 4. Using your trig circle, you get 1/2 minus the square root of 2 over 2. And we already know that to be negative 0.207. So again, we have negative values here. So what that is showing me is that we are coming down in the negatives and we are going up where the positives. And so I could say, where is this function increasing? It is increasing between pi over 3 and 5 pi over 3. Where is this function decreasing? And it is decreasing between 0 pi over 3 and 5 pi over 3 and 2 pi. Sorry for that kind of smashing it in there. But also look at this. If it is going down and then going up, that is creating a maximum, excuse me, getting a little too excited on that one. That is creating, going down, coming up, that's creating a minimum here at pi over 3, and it's creating a maximum here at 5 pi over 3. And so you can see that this first derivative test is not just, oh, let me check some y values. I can pick up increasing, decreasing, and I can also pick up where minimums and maximums are. And so pretty neat, this first derivative test you're going to use and repeat and practice quite a bit. And so make sure you're right on track with your understanding of the steps and your knowledge behind it. But again, a couple of the key things I want to emphasize to you is make sure you are plugging into that first derivative. Otherwise, your values are going to be off. And be careful you're not making little arithmetic errors along the way.